Hello everyone, welcome to In 5 Minutes. In this video clip, we'll discuss another problem on nodal analysis. In this case, you are given one circuit diagram. The question is find currents I1, I2, I3 and voltages VA and VB. So you can see they have marked all the three currents I1, I2 and I3 in the circuit diagram along with two voltages VA and VB. We have to find out these three values, and because we are doing examples on nodal analysis, we will solve this question using nodal analysis. If you observe carefully, they have not mentioned the values of these two resistors. That is because instead of providing the resistor values, they have given us some another information which is in the form of this two branch currents. This branch carries 30 ampere and this branch carries 20 amperes. So whenever any information like resistor value or voltage or current source value is missing, then instead of that some other information must have been given. Only then we can go ahead and solve whatever unknown variables that we have in the particular circuit. So in this case, we don't require these resistor values because we know the currents flowing through the branches, and hence we can find out whatever they have asked us to find, currents and voltages. Because we have to apply nodal analysis, the very first thing we have to do is mark the nodes in the given circuit. Now this is a very simple and straightforward circuit where there are going to be total three nodes. This is one node, this is the second node, and this bottom line acts as the third node. This complete line is at a single potential, so it acts as a third node, and as a common practice we always take this line to be the reference node. So this is the reference node with respect to which we will write the KCL equations. The voltage of this node will always be 0 because we have assumed this to be the ground node. Now let us mark the voltages at node A and node B. I'm going to call them VA and VB. That is simply because if you observe, they have marked VA and VB for us, which are the voltages across the resistors. Now this voltage across the resistor is also the node voltage. That is simply because if you look at the lower end of the resistor, which is at negative polarity, comes at the ground, and hence the upper node of the resistor, which is at positive polarity, it goes to the node A directly, and there is nothing else in between. There is only one resistor between the node and the ground. So please remember that whenever there is single resistor between node and the ground, in that case whatever is the voltage across the resistor will also become the voltage at that node, provided the negative terminal or the negative polarity of that voltage is at ground. So that is the case here. The negative polarity is at ground, and hence VA also becomes the node voltage. Similar is the case here. Negative polarity of VB is at ground. Nothing else between node B and the ground except this resistor. So VB also becomes the node voltage. So instead of defining node voltages as Vx, Vy or anything else, we simply call them VA, VB because they are already defined in the circuit and we have to find them. So we will write KCL equations in the form of VA, VB and find them out as per the question.